You know what is Poset? Yes. It must be reflexive, antisymmetric, and transitive. When these three relations satisfied, it becomes Poset. Okay. Yes. For example, this is a Poset. What is Poset? Z and the operation is less than or equal to. Why? Because this is, yes, this is a Poset. Because it satisfied reflexive, because equal sign is there, right? It is antisymmetric. A is less than or equal to B. Here B is not less than or equal to A, right? It can, yes, then A is equal to B, right? Yes. And this is transitive by default, right? No? 1 is less than 2, 2 is less than 3. Definitely 1 will less than 3. Yes. A is equal to B, possible. This is also possible. Here 1 is less than 2, means 1 is related with 2, but 2 is not related with 1. That's why this is antisymmetric, right? Yes. Yes. If A is less than or equal to B and 2 is less than or equal to 1, it is only possible when 2 is equal to 2. Okay? Or 1 is equal to 1. Yes, this is for transitive. For antisymmetric, 1 is related with 2, 2 is related with 3. Then 1 must be related with 3. Right? 1 is related with 2, 2 is related with 1. This is symmetric, not antisymmetric. If 1 is related with 2, then 2 must not be related with 1. Okay? Yes. BA is not there. AB is there. One AA and BB can also be there. Okay? Okay. See, Z plus an operation is division is a poset. Yes, positive integer means what? Natural number, right? Is a poset. How? It is reflexive because for all positive number, A divides A, right? This is true. It means A is related with A. Okay. For antisymmetric, A is related with B, but B cannot be related with A, and that is 2. If 2 divides 4, it means 2 is related with 4, but 4 does not divide 2, right? Yes. They divides if they are same value, then only they can divide. Okay. तो ट्रांजिटिव एंटीसिमेट्रिक में क्या देखना हमेशा? If A is related with B, then B cannot be related with A. It is related only when both are same. Okay. Yes. And for transitive, 2 divides 4, 4 divides 8. Then 2 divides 8, right? For all A, B, C belongs to Z positive, means positive integer. A divides B, means what? A related with B. B also divides C, means what? B related with C. Then A related with C, means what? A divides C. This is symbol actually. A divides B. Don't write like this. Okay. Always write a parallel line, straight line, perpendicular line. Okay. It means what? A divides B. This symbol is used in set theory. A minus B. This is what? A minus B. Okay. Example 2 divides 8 and 8 divides, let's suppose 40. Anything you can take. Then 2 divides 40. Satisfy transitive property. Right? This is a poset. Okay. Here next question is power set. A divides A. Okay. Where? No, actually this is parallel line. It is written like this, but you use parallel line. Okay. Yes, Poset. Okay. So this is a Poset. Is a Poset. How will you prove this? Yes. Why this is Poset? Let's suppose A is equal to AB. You can take any value, any set. Okay. Yes. Yes. Power set is what? One is 5. A, B, and set itself. Right? Yes. You know, for Poset, it must be reflexive. So you know this is completely set A, right? You can write what A comma B is a subset of A. It means you can also write A is a subset of A. This is same. It is reflexive, right? Yes. Second thing, antisymmetric. What is antisymmetric? Phi is a subset of A, but you cannot write A is a subset of phi, right? A is a subset of A, right? B is a subset of A. And A, B is a subset of A, and A is a subset of A. Both are same. Why? Because, understood? Yes. So it satisfied all the condition of antisymmetric, right? Yes, it is antisymmetric. Yes, this is A comma B means what? This and this are equal. Then only they are subset of each other. Yes. No, no, no. See, what is the definition of antisymmetry? If A is a subset of B and B is a subset of A, then what? A is equal to B. This is B, this is A, right? Let's suppose this is set B. Set B is subset of A is a subset of B. It means that what? A is equal to B. Understood? It is antisymmetry. Now last thing is what? Transitive. How will you prove transitivity? Phi is a subset of A. A is a subset of, let's suppose, AB. Understood? It means what? Phi is also a subset of AB. Right? Anything you can take. A is a subset of A. Right? You can take any example. This is one example. It means what? See this. Let's suppose you are taking A is a subset of AB, and you know AB is a subset of A, then definitely A is a subset of A. That is true? Yes. It is transitive. Therefore, it is a poset. Okay. Okay. Now one important thing. What is comparable and incomparable set? Okay, this is very important. Okay. So what is comparable? In a poset, let's suppose poset is what? A and relation is R. And you are taking A, B from set A. For all A, B belongs to A are said to be comparable when no. A comma R means A is the set for which you are going to check this is poset or not. R is the relation. Let's suppose relation is plus, division, anything. Okay. If A is related with B or B is related with E. Otherwise, this is incomparable. For example, okay, let's suppose 2 comma 4 belongs to what? Z plus, right? You know, 2 here operation is what? Division. 2 is related with 4. Why? Because 2 divides 4. These are comparable. 2 and 4 are comparable. Okay. 2, 4 are comparable. Understood? No. Comparable means what? Those pair which belongs to these relation, which satisfy this relation. 9, yes, 9 divides 81. So 9 and 81 are comparable. But 9 cannot divide 51 or 15. So you can write like this. A does not divide B. It means what? This is symbol of what? Divide is cut by half line. It means yes, A does not divide B. A does not divide B means what? 9 is not related with 51. So 9 and 15 are incomparable. Okay. Yes, you can note on this. Yes. Comparable or incomparable. Comparable means what? You have to choose those pair which satisfy the given condition of relation. Yes. Okay. You know partial order set, right? Yes, poset. Now when a poset in a poset when all pairs have are comparable, then it becomes total order set. Toset. Toset means what? Total ordered set. This is also called chain. So what is chain? In a poset, when a poset becomes what? Yeah, you can say when in a poset, if all pairs of element are comparable. Okay, in a poset, if all pairs of elements are comparable, it becomes chain. Or you can say total order set. Understood? Yes. For example, one divides two, two divides four. It is what? Comparable. Because and the relation is what? Let's suppose set age 1 to 4. Okay. 1 divides 2, 2 divides 4. Indirectly what? Okay. Yes. 1 is dividing 4 and 8 also. Okay. 2 dividing 4 and 2 also. 8 also. Yes. It never go downside. Yes. It means what? How many pairs you can find from this diagram? You can find 1 is related with 2, 1 is related with 4, 1 is related with 8. Understood? Similarly, 2 is related with, okay, itself pairs are also there. 2 related with 2, 2 related with 4, 2 related with 8. You cannot go out downside. And then last 8. These are, yes, yes. Okay. Uh, See, sometimes these are given. If these types of given, then you can do one thing. First, remove reflexive elements, right? Then remove transitivity. One is related with two. Two is related with four means what? One is related with four. Understood? If you draw the diagram of this, you will get what? One is related with two. One is also related with 8. One is also related with 4. Okay. 2 is related with 2. 2 related with 4. 2 related with 8. Right? So this diagram and this diagram are same. But you have to do what? First remove all the reflexive pairs, then remove transitive pair, because if 1 goes to 2, 2 goes to 4, then no need to write 1 to 4. Okay? Because yes, in Poset, in hash diagram, always use this type of operation. Okay? 1, 2, 4, 2, 8. So only these pair you will get. This is what? Comparable. Yes. Now see hash diagram. You know how to draw hash diagram? No. First what you have to do? Let's graphic on the okay. See, what is lexicographic ordering? Let's suppose two posets are there, A and B. This is first operation and this is second operation. Right? Suppose you take pairs from first poset and second from second poset. Right? This is what A belongs to A cross B, partition product. Understood? This is also a product of A cross B. These are said to be lexicographic if A1 is less than A2. Right? And B1 is less than B2. Understood? For example, suppose you are taking two sets, integer with equal sign and natural number with this, right? You took first pair from 3, 1 and minus 2, 2, which belongs to what? Z cross n, because first pair is integer, right? Now it can be negative. And second is always natural number, right? No, no. First set represent what? First integer. It is integer. So it can be negative or positive. Second pair is what? Natural number. This is always a natural number. Okay. Now you can see this A1 is less than what? A2, na? Similarly, B1 is less than B2. This is AND condition, means both condition must be satisfied. If any one of them fails, then it is not in lexicographic order. But this is what? Lexicographic order. Understood? Yes. If you choose another example, let's suppose you are taking minus 310, minus 310, minus 3 is not less than minus 3, right? Yes. This is wrong, not possible. Similarly, 10 is not less than 2. This is not possible. So this is not lexicographic order. Okay? Not lexicographic. Yes. Understood? Now see hash diagram. What is hash diagram? For drawing a hash diagram, it must be what? A poset. The first condition is what? Yes. So first thing is what? Hash diagram. A poset, right? Let's suppose this is R. Okay. R is anything, any relation. First thing is what? Remove reflexive pairs. Understood? Then remove transitive pair. Understood? Dry hash diagram of R x comma y such that x divides y. Okay. For all x y belongs to A. What is A? 1, 2, 3. 1, 2, 3, 4. Okay. So you know a set has how many elements? 4 elements. Right? Then if you find A cross A, how many relation will be there? You have to find those pair which divide by y, by x. So you have what? 1, 1. 1 divides 2, 1 divides 3, 1 divides 4. Isn't? 2 divides 2, 2 divides 4. 3 divides 3, 3 divide, no, 4 divides 4. Understood? So this is the relation according to the given condition, right? And this is Poset. You can check. Before drawing a hash diagram, it must be a Poset. This is a Poset. Don't worry, it is already Poset. No need to check. Now what do you do? Remove reflexive pair. Understood? Now remove transitive pair. How will you check transitive pair? A is related with, sorry, 1 is related with 2, 2 is related with 4. It means what? 1 related with 4. 1 related with 3 and 3 is not related with any others. Right? 3 already cancelled. Yes. So you have remaining pair what? 1 is related with 2 and 2 is related with 4 and 1 is also related with 3. So 2 and 3 must be on same level because 1 has 2 child. 1 is related with 2 and 2 is 4. Right? So this is what hash diagram. You can note this. Yes. In any order you can do, but these 3 steps are important. It is not important in which order you are writing. Okay. Fast, fast, आना जानती है। Understood? Yes. See this. You have to find a set and operation is division is given, right? What is A? 2, 4, 5, 10, 12, 20, 25. You have to find what? Hash diagram. Okay? Yes. See. What is the relation? Divides. So how many pairs you will get? 2 divides 2, 2 divides 4, 2 divides 10, 2 divides 12, 2 20. Similarly 4 4, 4 12, 4 20, 5 5, 5 10, 5 20, 5 25, 10 10, 10 20, 12 12, 20, 20. Right?
Yes.
But all pairs are not important for hash diagram. Remove reflexive property. Okay. Now you can remove what? Transitive property.
Transitive property.
Right? 2 is related with 4, 4 is related with 12. 2, 12 is not needed. 2, 20, sorry, 2, 10 and 10, 20. 2, 20 is not important. Right? Then 4, 12. 12 is not there. 4, 20. 5, 10. 10, 20. 5, 20 is not.
4, 4. Okay. Got it.
Right? After removing all the pairs, what you are getting? 2 is related with 4. Now check for 4. 4 is related with 12. Now check for 12. There is no 12. Right? 2 related with 10. Right?
Direct. Yeah.
2 related with 10. Here you can write 10. And for 10 related with 20. Understood?
Yes.
Now see. 4, 12, 4, 20. 4
related
is
with
also
10.
related with 20. Because this is not transitive. Right?
Yeah.
5 related with 10. It means what? 5 downside. Understood?
Yes.
5 related with 20. 5 related with 25. Like this. 10 related with 20. Okay? Yes. So you can write like this. 4, 10, 25. Don't think that 25 is greater than 10 and 20. That's why you can write here. No. Understood?
It should be like only considering the
Yes. You can consider like this. Suppose this is what? Grandfather. There are two brother. Both brother have two child each. Right?
yeah.
So they are first generation, second generation, third generation, like this. Okay?
Yeah.
Yes. This is hash diagram. Here you can observe two or three things. Maximal element. Maximal elements means top elements. Can you tell me what are the top element? What is top element? Top elements means what? That element which is on the top. So can you tell me what are the maximal elements?
So 12 and 20 and 25.
Yes. 25 is also top element because there is no any element about 25. Okay. Minimal element.
The minimal 2 and 5.
Yes. Everything starts from 2 and 5. Everything starts at these 3 points. Okay.
Sir, and in lattice, that is like the same
I
we use.
I tell you what is lattice. Don't worry. In lattice you will see bound, lower bound, upper
Uh,
bound.
uh,
Without drawing this relation, you can also draw a hash diagram. I tell you how.
Yes. That's it.
Done?
Yes. That's it.
Yes.
Yes.
What are topological sorting?
Well,
Arrange
the
all.
order
Yes. So first generation element is what?
2, 5.
2, 5. Then 4, 10, 25. And then you can also write this. Write like this 5, comma 2. Order doesn't matter. First level can be arranged in any way. Okay. You can also write 10, 4, 25. This is second generation and this is third generation. Okay. You can write 12, 20 or 20, 12. Yeah. This is what topological sorting. Right? Okay. D72 means what? Divisor of 72. What are the divisor of 72?
1, 2, 3, 9, 8. That is
24 also, right? Understood? 1 also divide 2, 3, 4, 5, 6, 7, 8, 9. Yes, these are the divider. Okay. If you find the relation, it will waste the time. Don't write the relation. Okay. You can do directly. How? 1 divides 2, right? 2 divides 4. 4 divides 8. Okay. One more element is there. 16. No, 16 is not.
so the relation is divisible. That is the relation
Yes.
divided by
8 divides 24. And 24 divides 72, right? Yes. But 1 also divides 3.
yes
3 also divides what?
24.
6.
Passing.
6 divides 12. 12 divides 24. 12 also divides 36. Right?
Yes.
Yes.
So 2 also divides 12 and 6.
Yes. That's why you can attach the 2 divides 6. 4 divides 12. Right?
So, yeah.
Yes. Now check 3 divides 9. 9 divides 18. 6 also divides 18. 18 divides
36.
36. 30 divide.
20.
Now you can see all element is done. So you can write properly how 1 has 2 generation, has 2 child. Okay. 2 has 2 child, 4 and 6. 3 has 3 and 9. Right? Understood? 4 has 2 child, 8 and 12. 9 has only 1 child, 18. Understood? 8 has only 1 child, 24. 12 has 2 child, 24 and 36. And all these have only 1 child. Understood? Now you can check every pair. 4 also divides 36, right? Now, see, 4 is connected with 36, right?
Yes.
6 divides 24. See, 6 and 4 are connected. 24 are connected. This is hash diagram. Understood?
Yes.
What are topological sorting?
So sorting them according to their from base to top
Yes,
values.
1, 2, 3, 4, 6, 9, 8, 12, 18, 24, 36, 72. Right? What is maximal element?
So 72.
Only 72.
Yes.
If maximal element has only one element, then you can say greatest element. Okay. Greatest is what? Unique.
Yeah.
What is minimal element?
Sir, but
One generates everything. Means what? One divides every number. Understood?
so unique. Unique.
Yes. This is also unique. That's why you can say least element. If
Sir, is
unique,
it the same as
if minimal element, let's suppose there are two minimal, one or two. Okay. Then this is not least element.
Sir, is it same as saying greatest upper bound and the lowest upper?
That
Sorry,
is
lowest
different.
upper.
That is
That is
different
different.
thing. I tell you. Don't worry. I come there. Nine does not divide 12. That's why there is no connection between 9 and 12, right?
Yes.
You have to go from bottom to top. Never go from top to down or left to right or right to left. This is important rule.
Yes.
Hmm. Now see this graph. Can you tell me what is greatest element in this graph?
Sir, 8 and 20.
8 and 12. What is maximal element? What are maximal element?
Sir, 8 and 20.
Maximal element means what? Top element, 8 and 12. I am asking what is greatest element. There is no greatest element. Why? Because maximal element is not unique. In maximal element, only one uh, element is not there. That's why this is not unique. Okay? You cannot decide who is more powerful because they are at both, they are at same level, right? Understood?
Yes.
Yes. Now tell me what is minimal element.
Sir, 1.
Only one. And this is unique. Unique means what? Only one element is
Sir,
there.
how did you write greatest element as 5?
Because maximal element is not unique.
Oh.
Here, minimal element is only one element. One.
Yes.
This is unique. Unique means what? No other than one is minimal element. That's why this is least element. Least means what? One divides everything. Right? Least elements means what? One divides everything. A greatest means what? Every number is divisible by 8. This is not true. Why? Because 6 does not divide it. Understood?
Yes.
Yes. Greatest elements means what? Every elements satisfies A. Let's suppose maximal greatest element is A. Okay. Least element means what?
But it means it should be unique.
Understood, I think. Right now?
Yes. So least is 1 and greatest is 10.
In this graph, one is the least element because minimal element is unique. But maximal element is not unique. That's why there is no greatest element. Okay.
Yeah.
Understood? You can note
Yes.
this. This is unique. And this is not unique. Why not unique? Why not greatest? Because you cannot decide which is more powerful. Understood? You know, uh, greater, greatest. Wherever you use superlative thing, it is what? It is not greater than that things, right now?
So super related.
Yes. Draw a hash diagram of power set A. P of A, and this is what subset, right?
Yeah.
And where A is what? Let's suppose A, B, C. Also find what? Greatest and least element.
Yeah.
Okay, now see. What is A? This is question and this is my solution. A is what? And what is power set? Phi A, B, C, AB, AC, BC, right?
Yes.
ABC. Understood? Okay, now see. You know, phi is a subset of what? A, every element, right? ABC. A is a subset of what? AB, right? AB, right? And B is a subset of B and BC, right? And C is a subset of that set which contains C, right? Yes. And AB is a subset of ABC, AC, and AC, right? Yes. This is what? Hash diagram of this. But it really looks like this, right? Yes. Structure are same. You can check. This is same level. This is second generation. This is third generation. Okay. So what is maximal element? ABC. Because ABC is a subset of everything. And this is unique, right? Unique means what? Only one pair, only one element is there, right? If this is unique, then you can say this is the greatest element, right? Okay. What is minimal element? Phi. And this is also unique because phi is the subset of everything. That's why this is also unique. This is least element. Okay. Yes. Yes. A is given. right? And you know topological sorting, right? Yes. Now see, one, two, three, four. One, two, three, four. Five. A, B, C, D. Okay. Now tell me, okay, first tell me what is maximal element of this graph, hash diagram? 3, 4. Okay. But this is not unique, so greatest is 5, right? Yes. What is minimal element? Only 1. So least element will be 1, right? Per second. What is the maximal element? 5. And this is unique. Greatest will be 5, right? Minimal element is what? 1, 2. But this is not unique because 2 elements are there. Understood? Yes. Now tell me maximal element of this. E, right? But this is not unique. Understood? Minimal element is 1. So this is unique. Unique means what? Single element. Understood? What is the maximal element? Greatest will be minimal AB. Least will be 5. Right? Right? Because this is what? Not unique. Very good. Now next thing is what is the maximal element? 6. Greatest will be 6. Minimal will be least will be 1. Understood? So draw all these diagram. right? Understood? Okay. Now see lattice. Okay. Before going to lattice, first I tell you what is upper bound and lower bound. Hmm. Upper bound. Upper bound of suppose you are taking upper bound of 1 2. So all the elements which are upside of 1 2. So including 2 3 4. Why are you including 2? Yes. First you have to take what? Upper bound of 1. What is upper bound of 1? Including 1 also. Okay. Upper bound of 1 union upper bound of 2. Okay. So upper bound of 1, whatever element you are taking upper bound, you can take that element also. So upper bound of 1 is what? 1, 2, 3, 4. Right? Not union, this is intersection. Okay. And upper bound of 2 is what? 2, 3, 4. So what are the common elements? Understood? Yes. If I ask you upper bound of 2, 3. 2, 3. Right? It means you have to take upper bound of 2. 2 is what? 2, 3, 4. And upper bound of 3 is what? Only 3. So what are the common elements? 3. Understood? Yes. If I ask you upper bound of 3, 4. Upper bound of 3 is what? 3 intersection 4, which is nothing, 5. So there is no upper bound of 3, 4. Understood? There is no common element. Okay? Yes. Now see least upper bound. Least upper bound of 1, 2 means what? First find the upper bound minimum. Least means what? Bottom value. Bottom value of what? Upper bound. Bottom means what? Least value. Okay. So bottom, first find the upper bound of 1, 2. 1, 2 upper bound is what? 2, 3, 4. So out of these three elements, which element are at the bottom? 2. Yes. So least upper bound of 1, 2 each? 2. Least upper bound means what? Whatever you are getting, choose the bottom value. Means least value. Value means bottommost value. Okay. If I ask you what is the least upper value of, LUV. LUV means least, you can write a least. Least upper bound. Least upper bound of 2, 3. So if single element is there, then no need to compare. That is the least element. Okay. Understood? Yes. Only 3 is there. So least upper bound will be what? Only 3 is there. Okay. Write this. Right? Now see. Lower bound. Lower bound of 1, 2, 3, 4. Means what? All lower bound of 3 intersection lower bound of 4. Okay. So 3 means what? Including 3, take all the value which are going downside. Right? 4, 2, 1. So what are the common elements? 2 and 1. No, no, no. Upper bound means what? Upper bound means going upside. Lower bound means this is lower bound. Lower means we are going lower side. Okay. And greatest lower bound means what? Greatest value. Greatest value means topmost value. Yes. Greatest value. Greatest means what? I told you already what is greatest. Greatest means bottommost, topmost value, right now? So what is the greatest value? Because 2 is upside, right? Now tell me what is lower bound of 1, 2. 1 is 1 and 2 is 2 1. But 1 is single element. So greatest, yes, greatest will be sent. What is lower bound of 3 to 3 to means what? 3 to 1. Right? Intersection 2 is what? 2 1. So intersection will be 2 1. This is lower bound. But I am asking greatest lower bound. 2. 2 is the greatest value. Greatest means top value. Yes. Note down this. Right? Yes. Now what is lattice? Yes. What is lattice? If a hash diagram, yes, I tell you, if a hash diagram, if in a hash diagram, all pairs, every pairs must have GLB and LUB. Every pair must have what? GLB and LUB. Then this is lattice. Okay? Yes. For example, A, B, C, D, E, F. Right. First we find GLB and then find LUB. LUB is represented by this symbol R and GLB is represented by AND symbol. Okay. So first we find what? GLB. How many elements are there? 6. Right? Okay. Now see. First of all, this is symmetric actually. A lower bound of AB. Lower bound of AB is what? All things including B, right? Na? BDF, right? But the greatest value is what? B. Understood? Because no. Because you have to check every pair, na? I write there all pairs. Understood? Yes. What is greatest lower bound of AC? C. AD, D, E, F. Understood how why I am writing like this? Understood? You can see here. Suppose I am finding AD. What is lower bound of AD? Lower bound of A is all thing, right? And lower bound of D is what? DF. So what are the common elements? D and F. Understood? Okay. See. First, first I tell you simple question. Like this. Then how can you check F for every pair? Here they only write what? Every pair of element has an LUB and GLB. You have to verify. They did not solve. Understood? Yes. So you have to show this by using matrix form. In class, they do not use a matrix. Hmm. Check whether the following poset are lattice using their hash diagram. They only write what? It's a lattice since every pair of elements has an LUB and GLB. Then how can you say every pair of element has LUB and GLB? Right now? Without finding you, how can you say? And this is wrong. Who wrote this? Question number 2. This is what? This is lattice, but they write not a lattice. And they give reason what? Since B.Sc has no lower bound, least upper bound. So can you tell me the what is upper bound of B.Sc? What is the upper bound of B.Sc?
B.Sc. Right?
What is the upper bound of B.Sc? Upper bound of B is what? B, D, E, F, right? And upper bound of C is C, D, E, F, right? Yes. So what are the common elements?
D,
E, F. So out of these three elements, can you tell me the least value?
20.
Least means what?
Oh, least.
Yes, there is no least value because this is not unique. Understood? Least means what?
Uh,
Out of these three, can you decide which one is on the bottom?
no.
No, you cannot decide. So this is not a lattice. Understood? Because the pair B.Sc has no LUB. But you have to show by matrix. Uh, do you have notes of class?
So now I don't know.
Okay.
Not.
See, I show you how to prove matrix.